Hi everyone, welcome back. So I've heard from a friend that this question, the string match, is very cryptic and hard to understand. I hope I can get it right, but let's go. So for this question, we're given a permutation perm of n plus 1 integers of all integers in the range 0 to n. Let me hold up. A permutation perm of n plus 1 integers of all the integers in the range 0 to n. Oh, okay. So 0 to n are indexes. And because it's 0 indexed, you have n plus 1 permutations. Okay. Can be represented as a string of S of length n, where Si, every character in the string is equals to I if permutation of I is less than permutation of I plus 1. And item at Si is equals to D if permutation of I is more than I plus 1. Okay. Okay. So given a string S, reconstruct the permutation perm and return it. If there are multiple valid permutations perm, return any of them. Oh, okay. So perm is a sequence of numbers. So to make it clearer, I will be reverse engineering it. In the first example, we can see that the output is a valid permutation that can be expressed as this index over here. So bear with me. It took me some time to understand this as well, but perm is equals, let's say perm is equals to 0, 4, 1, 3, 2. So this is not the only possible permutation given S, but let's just say that perm is this output is perm over here, and S is expressed such that I is equals to the first index. Let's say I is equals to 0. In this case, S at 0 will be equals to I if perm I, if the first index of I of perm is less than the and then the adjacent perm. So in this case, this 0 index, the 0 index item at perm is lesser than the item just on the right of it. So in this case, what this means is S is saying that this should be I. So this makes sense. If perm is of length 5, then S would be of length 4, because S is really the characters I and D are representing the increasing sequence or the decreasing sequence in perm. So in this case 0, 4, this makes sense because it's increasing. Now 4, 1, in this case the current value at the first index is more than the one to the right of it. So in this case it's decreasing, and that's why this is set to D. So this is D. And the next sequence from 1 to 3 is increasing, so that is I. And now from 3 to 2, that's decreasing, so that's D. So that gives us the initial input ID. So this is to illustrate how so to understand the test cases, we reverse engineered it and start off from the output and try to see how that output maps back to the input. I guess this is a pretty good tactic to better understand the question if by any chance reading and translating the input to the output doesn't make sense. I personally found it quite hard for me to understand how ID maps to 0, 4, 1, 3, 2, but reversing this interpretation helped me better understand the question. So okay, that's the answer. So if you have I, then this means you need to have a number that is increasing all the way. So you have 4 numbers that increase all the way, such that you get 0, 1, 2, 3, 4. And if it's decreasing, then it will be 3, 2, 1, 0, 1. Okay. And in this case, the length of S over here will range from 1 to 10 to the power of 5. And SI is either I or D. Okay. Okay, looks good. Actually, maybe that's a way to do this easily. Yeah, we can just initialize the first number to be 0. And if we see that a character is I, then we would just take the previous number, which is 0, and just increment it by 1 and put it in front. And if we see a D, then we would just decrement 1 by 1 and give back 0. And that's the sequence. We can do that, right? So let's set S to be equals to ID, ID. Let's initialize a list of length S plus 1. So let's set this to, let's call this perm. This will be a list of integer, and this will be equals to, let's say, 0 multiplied by length of S plus 1. So now that we have this, we can do for char in S. Actually, let's do range of length of S, and we'll be using this index to, yeah, actually just range from 1 to length S plus 1. So we can use this index to populate perm. So now we can get the corresponding char in S char to be equal to S at index minus 1. Let's call this perm index to make it clearer what index this is. So since we're starting from 1 and we want to read index 0 at S, so I will just do perm index minus 1 to read index 0 of S while we decide what value to put inside perm. Okay, so you can have variations of this. It's up to you. You can choose to start off from range 0. That's totally fine. But the idea would be the same. And once you're done, if S char is equals to I, then in this case, what this means is we should set perm at perm index to be equals to perm at perm index minus 1 plus 1. So there must be an increase from the previous index to the current index. Else, by elimination, it must be D. So it will just be perm index equals to perm index minus 1 minus 1. So it's a decrement. It's a decrement for the current index from the number on the left side of it. And the first number would be 0 as we initialize in line 8 over here. So now that we have this, let's try to trace this out with this simple input over here. Let S be equals to ID, ID, and let's see what we get. So perm is now equals to 0 multiplied by length of S, which is 4, plus 1, 5. So this will give you 0, 0, 0, 0, and 0. So a list of 5 zeros. And the perm index in this case will be equals to 1. So now S char will be equals to S at index 1 minus 0, sorry, 1 minus 1, so index 0 at perm. So in this case, sorry, 1 minus 1 at S, so in this case is I, the first character in S, which is I over here. And since S char is equals to I, we will set perm at perm index. So perm index in this case is 1. So we're referring to this character over here. This will be equals to perm index minus 1, which is this, plus 1. So this will be set to 1 over here. So now we will move on. Let's set perm index to be equals to 2. S char will be equals to the character at 2 minus 1 of S. So this gives us D. So since D is not equals to I on line 10, we will hit line 13. So perm index 2 will be equals to perm at index 1 minus 1. So this gives us 0. So we set this to 0 and we're done. Let's set this to perm index 3. So now 0, 1, 2, 3, we are looking at this index in perm now. So S char at perm index 3 minus 1. So this character over here, I, S char is equals to I. We hit branch 10. We evaluate line 11. Perm at index 3 is equals to perm index 3 minus 1. So this plus 1. So 1 over here. And else perm index equals to, oh sorry, this is, we can move on to the next iteration on line 8. So for perm index equals to 4, now S char is at index 3, 4 minus 1 is 3, so the final character in S. So since this is D, we will hit line 13, and this will be perm index at 4, so here, equals to perm index minus 1, giving us 0. So this looks good, and there is no rule to say that there is no duplicates. So this is valid because the question didn't say we can have, didn't say that every element in perm must be unique, and they also allow us to return any of them. So yeah, this works. Okay, let's code this out. So now let's define perm, pretty much the repeat of what we just traced, but length S plus 1. Okay, so for perm index in range 1 to length S plus 1, if S is of length 4, then this will iterate from 1 to 4 because it's exclusive of 1 over here. So 1, 2, 3, 4, 1 to 4. We will change the elements in perm from 1 to 4 over here. So S char, we get the corresponding S char in perm index minus 1. In the first iteration, it's just pointing to the first character in S. So if S char is equals to I, then we would set this current character to be the previous number plus 1. So this would just be perm index equals to perm index minus 1 plus 1. Else, we do the same for this index, but we set this to be a number smaller than the current number on the left of it. So that's pretty much it. And once we're done, we will return a list of integers, which is the perm itself. So let's run this against the test cases and see if this passes. Wow, okay. Multiple valid permutations. I see. Okay. I guess this question meant that you needed a number that is in this range 0 to n, and you cannot have multiple duplicates of that. The numbers in perm must be unique and must be in the range 0 to size n. And n in this case is of length s. So 0 to... So if you have length, let's say your perm is of size 5, then the number of integer in the permutation must be 0 to 5. Okay, looks fine. Okay. 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 Can we use a dictionary to keep track of what permutations has been used? Let's say you have a dictionary, let's say a set, and let's say you use 0 at the start. Let's say you use 0 at the start, and then you see I, and you increment this by 1. So you put 1 inside here, and now you see D, then you have to decrement it. The only valid number that you could have used is 0. Does this mean that you should always use the highest number possible when you see a D? That might be right. That might be right. That might be right. What if we have a set of integers that represents the range of numbers that we can use, so from 0 to n. So let's say s is n, so the length of s is n. So the set will contain numbers okay, but if you decrement this if you increase it, so from 0 you increase it, so 0 to 4, what if it says increase on the next step? So setting this to the highest number doesn't always work, does it? No, it doesn't. If, for example 2, we just set this to 3 right away, we will no longer be able to increase it even further. Should we construct it from the back? Not that it matters. If you reverse that input, it will still be the same. Should it be a sort? Should we sort this? Let's say you start off with 0, 1, 2, 3, 4. And you see ID. What will you do? I, okay. And you want to decrease this. So what if you swap this? And you want to increase it again. And then you want to decrease this. So 0, 2, 1, 4, 3. Does that look good? Yes, swapping does work. Let's try sorting then. Instead of creating our own sequence, let's define perm to be equals to I for I in range 0 to length of s plus 1. Yep, works. So if s is of length 4, then perm should range from 0 to 4. So this makes sense. So now, what if we iterate through all characters in perm let's iterate by index so that we can access the previous element easily. So let's do index in length of perm. So if let's get no, actually let's range this from 1 to length of perm. So if this is length 5, then this will iterate from 1 to 4. And let's say s index to be equals to index minus 1. Let's set this to perm index. Okay. And now, let's get the S char. S char will be equals to S at S index. And if S char is equals to I, then we will do if perm at perm index is less than perm at perm index minus 1. In other words, if the current index value is less than the previous value, so let's say this is 0 and this is 1, but we see that S char is equals to I, then this is not valid because this is supposed to be increasing. Then we will just do perm index, perm index minus 1 to be equals to perm index minus 1, perm index. We swap the order such that this increasing pattern is now achieved. So we will swap these two characters, these two numbers, and we will get this solution. Else, okay, actually there's no else here. Else in this case, if this is decreasing, then if there's a chance that if perm index is currently more than the item on the left, so for example, this is a good example where 1 is more than 0, but you encounter S char equals to decreasing, then this is incorrect, right? Because this is supposed to be decreasing. Then what we will do is we will swap the two numbers together such that this is still achieved. So yeah, this looks great. Let's do perm index minus 1 equals to perm index minus 1 perm index. Okay, and we return perm. So I got screwed over the first implementation because I misinterpreted the question, but hopefully this was a good learning lesson for the mistakes that I made in this question. So let's try tracing this again with S equals to ID. Let perm be equals to, say, range 0 to length S, so 0 to 4, 0, 1, 2, 3, 4. And let's try tracing this on line 12 again. So perm is equals to 0, 1, 2, 3, 4. Let's set perm index to be equals to 1 for now. So S index over here will be equals to perm index minus 1. So 1 minus 1 equals to 0. S char in this case would be S at S index, which is 0. So this gives us I. S char is equals to I. And if S char is equals to I, which is true in this case, let's try getting perm index. In this case, perm index at index 1 is 1. Perm index plus 1 is equals to, let's bring this to the side. If this plus 1 is equals, oh sorry, minus 1, sorry. Minus 1 in this case is 0, so this equals to 0. So if 1 is less than 0, which is true, this evaluates to true, then we will swap this with the previous number. So now we will swap this to this, and we will continue. So yep, we will continue. Let's set perm index to be equals to 2. S index would be 2 minus 1, giving us 1. S char at index 1 is D. So let's go to D. Okay. And let's copy this and paste this on line 19 for tracing. Perm index at index 2 is equals to 2. and perm at 2 minus 1 is 0. So is perm index 2 more than 0? Yes, it is. So we swap them, giving us 2, 0. Doesn't this violate the situation? Doesn't this violate the previous? This violates the previous. Woo! This violates the previous. So this algorithm doesn't work either. Interesting. What other approach would you use? Let's try doing it all towards the end and see if there's a pattern. So if perm index is equals to 3, S index is 2, we get I, and we hit this branch. Perm index equals to 1. Perm index at index 3 is equals to 3. Perm index at 2 is 0. So is 3 less than? Nope, it's not. So we will swap this. So this will give you back 3 and 0. And now let's start off with perm index 4, which is the final one. S index will be equals to 3. Character equals to D. Perm index at index 4 would be 4. I minus 1 will be 0. So in this case, oh sorry, I'm supposed to be tracing on line 19, not 16. So 4 and 0. In this case, it's true. So we really swap this to 4 and we get 0. So 0, 4, 3, 2, 1. Let's try it again. So I increasing, D decreasing. So we swap this again. 3, 2. I increasing, D decreasing. Okay, we try again. I increasing, D decreasing. I increasing, D decreasing. So if we keep doing the sort, it might still work actually. Let's try defining an additional condition met equals to boolean equals to true. Let's set this to false, should we? So let's set this to false. Actually, let's set this to true first. While condition while not condition met, keep doing this bubble sorting sort. Let's set this to false first so that this will start off as false. And let's set this to true on the start. And if that is a swap that happens, then we will set condition met to be equals to false. And we will do the same over here as well. And we will just keep swapping until we get perm equals to true. Okay. Looks like this does work. Let's run this. And this passes the test case. But it's really very slow. Is there a better way around this? Let's check the solution. Really? But what if you see a D and an II afterwards? Then aren't you kind of screwed? Say we have a match for the rest of the string I1 S2 using n distinct elements. Notice that it doesn't matter what elements are, only that they are distinct and totally ordered. Putting 0 or n at the start will match the rest 1, 2, 3 can use the matching we have. Keep track of the smallest and largest element we haven't placed. If we see an I, place the small element, otherwise place the large element. Keep track of the smallest and largest element we haven't placed. Apparently this question is quite confusing. We were not the only one that found this confusing. Okay. But there is a better intuition, a better solution that they thought of. And the idea is if you set S to be equals to I, we'll put 0 as the first element, and is 6 to D, and put n as the first element. So let's say you're the match for the rest of the string. So if you see another, so let's try out this solution. Let's say ID. If you see I, your first intuition is to put the smallest element. If you see D, then the solution is to put the largest element that is possible. And if you see I again, then you'll put a very small number that you had never seen before. And if you see a D, then you will put a very hard element. Sorry, I, D, 4, 1, 3, 2. Oh, I see. This is a much better solution than the one that we have. Okay, that's pretty interesting. That's a really smart way to think about it. Why didn't I think of that? That is so much better. The first solution that we used is a bubble sort like algorithm where we just initialize this as 1, 3, 2, like 0, 1, 2, 3, 4, and we just keep sorting this until we get the answer. In this case, this would take on, this is similar to bubble sort. So if n is the length of S, then this would take up to ON square. This would take up to ON square in the worst case scenario. But if we use this tactic of choosing the largest number possible. If we see I, then we will get a very stable solution. So that's pretty much it for this solution. So let's try setting, let's see. Okay, let's restart this and let's try sorted perm to be equals to 0, 1, 2, 3, 4. Let's set the smallest to be equals to index to be largest to be equals to, let's say, length of sorted perm minus 1, smallest will be 0, and let's start off from here. And let's call the final array perm. So we will do an iteration across S for char in S. If char is equals to I, then we will do, okay, let perm be equals to, okay, fine, a list of string, list is of integer, sorry. So this is a list. And if char is equals to I, then we will append perm. Sorted perm will be equals to I in range 0 to length of S plus 1. Okay, so if S is length 4, this would be 0, 1, 2, 3, 4. So sorted perm is equals to this. Perm is equals to empty string. Char is equals, for char equals to I. Char perm append. If the char is equals to I, that is in our, if the first number is equals to I, should we have some logic to set the first number to be a small number or large number first? Yes, we should, don't we? Yes. So let's do it at the start first. Let's check for smallest index. Let's set this to 0. Largest index will be equals to length of S minus 1. So this will be equals to S4. No, sorry, it should just be length S, because perm is S plus 1, right? So largest index will be equals to, yeah, it'll just be S length S. So largest index will be equals to 4. Smallest index will be equals to 0. And if S0 is equals to I, then we will set perm. Yeah, let's just define it at the start so that we can append stuff through it. Perm will be appended with sorted perm at smallest index. Sorry. Yes, sorted perm at smallest index. And it's in our interest to add the smallest number at the start if the first S character is I, so that we have more numbers to play with if the subsequent characters turn out to be I. So we append it with the smallest index, and since we technically use the smallest index, we will plus equals 1. We will increment smallest index, so next time if we want the smallest smallest number possible, we will be able to target the next smallest, which is 1 over here. So once we're done, that's pretty much else. We will append perm with the largest index, and we will decrement the largest index by 1. So once we're done, we can start iterating all characters in S. So if the character is equals to I in this case, like we will repeat looking at I again, then we will append the largest element over here. So we will append the largest element. So we will append 4. We will append 4, which is the largest, and we will decrement largest. Yeah, makes sense. So else, we will append the next smallest number. So smallest index and smallest index plus equals to 1. Yep, looks great. And once we're done, we can return perm. Okay, so now we see that we got this. Let's try tracing this out with this current test case. I went and jumped the gun to implement the solution, but now let's try checking if this current solution makes sense. So sorted perm is currently 0 to 4. Okay, let's just start off with S equals to ID. So currently we initialize sorted perm to be equals to 0 to 4. Smallest index is at 0, and the smallest index represents the smallest element available to us to set to perm. And the largest index in this case represents the largest number that we can add to perm. So if the first index is I, then we will set the smallest number possible into perm. So we will do sorted perm. We will append sorted perm at index, at smallest index. Looks like I make a mistake here. Thank goodness we traced. So this would add perm with sorted perm at smallest index, which is 0. So we will add 0 to perm. And we will increment the smallest index by 1. So the next time we want to get the smallest number, we will use this index instead. So in this case, because we started off with I, we started perm with 0 in this case. So now we pass line 11 to line 16. Now we're at line 18. So char in S. So the first char is I. If char is equals to I, which is true, in this case this is true, let's bring this towards the right so that we have more space. In this case this is true. And we are appending perm with sorted perm at largest index. So we're appending 4. So we append 4 to perm, 0, 4. And we decrement the largest index. So now it's 3. So we are done with this. Let's go to the next iteration. The next character is D, right? Yes, it's D. So 19 is false. So let's go to else here. True. And in this case, we are appending the smallest number since this is a D over here. So we will append the smallest index, the character at the smallest index over here. So we'll append 1 to perm. Okay. And we increment the smallest index. So we get 2. And we continue. So now we are at index 2 of S. And if character is equals to I, in this case this is true. This won't be evaluated because this is true. And now we're appending perm by the largest index. So at index 3, 0, 1, 2, 3. So 3, we append 3. And this is equals to 2. So at this point, we have this expression and we're finally at the final character in S, which is D. So since this is false on line 19 and line 22 is true, we will append perm with sorted perm at smallest index, which is 2 over here. So this gives us 04132, 04132. Okay, this is the same solution that's recommended in solutions. Did I make? Oh, sorry. I for I in range length I. Sorry for the typo over there. But we replicated the solution in the solutions. We cheated a little by looking at the solution. We used the bubble sort algorithm previously for the first approach, but that wasn't the most efficient. That's O(n) squared if n is the size of S. So that's not great. But this is great. This is the most efficient probably. Wow, why is this wrong? Yeah, this is wrong, ain't it? Yeah, I never thought of this test case. So if you have if it's the intuition was to add the smallest index, the smallest number, right? Yes. Oh, I have it backwards, didn't I? So if it's equals to I, then we should add the smallest index, and the smallest index plus equals to 1. And if it is a D, then we should add the largest possible index that we have. Really? 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 Doesn't sound right. Okay, it doesn't sound right. Let's try tracing this again. Let's try it with this test case this time. Okay, let's try with ID first. So smallest index will be 0, largest index will be 4, and let's say 0, 1, 2, 3, and 4 again. I is equals to S0. Okay, I is true, so in this case we append the smallest number. So let's restart this with an empty list. So we append this with the smallest index. So in this case, actually, yes, the rules should be the same as what we have on line 11 to line 16, right? So in this case, this is 0, and we will increment the smallest index to 1. So now if we see I again, then we'll increment, the next one is I, right? So if it's I, we add it with the smallest index. So in this case, this is 1. So character equals to I. This is true. And we append the smallest index as always. So we get 1. We append 1 into perm, and we increment smaller index by 1 again. So we get 2. Now the next item is D, the second character in S. Now this is not true, this is false. Let's continue on line 22. Perm append largest index. So in this case, the largest index is 4. So we will append 4 here, and we will decrement it by 1. And let's continue. Let's do I. This is the third character in S. Let's append this to perm again. So this will be equal to sorted perm at smallest index. So this is sorted perm at smallest index. So here 2. So let's append 2. and let's increment smallest index. Now we get this. Now we try largest index. So sorry, D, character is D, and in this case this is false, so we are here on branch 22, 23, and now we're appending the largest index, which is at index 3, so 0, 1, 4, 2, 3. Okay, that's the answer. Now let's try tracing this with the test case that just failed. So I. So in this case, sorted perm is as usual. Let's refresh this to the previous results. Let's empty out perm again, and let's try tracing this once more. So in this case, we start out with I, so we will add the smallest index. So in this case, perm would be 0, and smallest index will be incremented by 1, because we hit this branch over here. Now we will iterate through characters in S again. Now let's set character to the first character in S, so character equals to I. So since character is equals to I, we'll append it with the smallest index, 1. Increment this by 1 again. We hit the same branch again. For the second I in S, we will append 2, because index 2 in sorted perm is 2. And let's now character I is now targeting the final I in S. That is here. So, oh yes, of course. This should be 0, 1, 2, 3. This should have been 3 actually. Sorry for the mistakes in tracing. Now we're at the final character. So now it should be, yes, this should be 3 in it. Yes. So now I character equals to I. This is true. So we'll append the character at index 3, giving us 0, 1, 2, 3. So this solution looks right. I made a mistake on line 19 to line 24 just now for the implementation, but this should work fine this time. So let's run ID, list index out of range. Why would that be the case? Oh, minus equals on line 24. Sorry for not tracing correctly. Oh my goodness, why is this wrong? Okay, this is the increase, but this is the decrease. So this didn't achieve the right answer. How would you have done this though? Should we have iterated from here? Yes. And the final index will always converge to the final one, right? So perm.append sorted largest index. This should get the answer. Okay, that's the answer. So the mistake was that after I use the I here, I should start off with the next I, and the final integer to be added to perm should be the final index that is unused. So even if I had changed this to smallest index, that's fine, because once you are at the final index, the smallest and the largest index will always point at the same number. So if I had changed this largest to smallest, it would still work. So yeah, looks great. So this was a really challenging question. I took way longer. If this was a technical interview, I would have flunked it pretty badly. But I hope this was a pretty candid demonstration of what can happen when you trace. It is still possible for you to make mistakes even if you trace. So in this case, the time complexity, if the time complexity is O(n), if n is the size of S. So over here, line 11 for sorted perm, this for comprehension that we use on line 11 would be O(n), approximately O(n), so to reconstruct sorted perm. And we go through one iteration here, and we go through the rest of the iteration across S over here. So from line 16 to line 29, this is O(n) as well, because we iterate through S. So afterwards, we append it with the final element that is not used, and that's pretty much it. So this gives us a time complexity of O(n). For the space complexity, in this case, this would be O(n), 2 over here on line 12, because we keep a copy of sorted perm. And sorted perm, if it wasn't clear during my tracing, sorted perm is for us to keep track of what are the highest and the lowest numbers that we have in perm. And we also keep track of another copy of perm on line 16. So in this case, this will be O(n) as well. So our space complexity in total is O(n), 2O2n, because of the two copies of perm on 12 and 16. But if you remove the coefficients, that will give you O(n) in this case. So yeah, this corresponds with the time and space complexity provided in the answer. So I made a couple of mistakes when I tried to do the question with reference to the solution. So the mistake that I made earlier was that I reused the first character in S to decide what characters should come next in perm. But that shouldn't be the case. Every single character should be used once. And because I reused it, I caused a small little bug on line 25 to line 31. So that threw me off quite a bit. So that's pretty much it. That's how I would have solved this question if this was in a technical interview. To be fair, this wasn't the best. I'm not exactly proud of this demonstration, but I hope this was a candid showcase of what would happen in a technical interview. Even with tracing in the best of times, you would still mess things up sometimes. So I learned a little bit from this question. I hope that you learned it as well. And with that, that's it for this question. If you find this useful, please give us a like and subscribe, and we will see you in the next video.